Good morning, good evening, good afternoon. Hey, folks. I think we're going to wait a couple more minutes before we get started. So, I don't know, we'll give it 2 more and then see what happens.
Okay, I think we can start right now. So thank you everyone for joining the first WISH working group meeting. Unfortunately, it's online, but that should be addressed in future meetings. So Sean, can you go to the next slide, please? First, we're going to start with the agenda. We're going to start with the normal administration. The usual IETF policies are in effect. You agree that you follow the IETF process and policy. If you, for example, aware that any IETF contribution is covered by patent or patent application that are owned or controlled by you or your sponsor, you must disclose that fact or not participate in the discussion. As a participant or an attendee to any IETF activity, you acknowledge that written, audio, and video and photographic records of meetings may be made public. Personal information that you provide to the IETF will be handled in accordance with the IETF privacy statement. As participant or attendee, you also agree to work respectfully with other participants. Please contact the Ombuds team if you have any question or concern about that. Definitive information in the documents listed below and the other IETF BCPs. For advice, please talk to the working group chairs, Sean or myself, or ADs. All right, next slide. So welcome again. We had made on the mailing list a request for Jaber scribe and note taker. Did we have any volunteer, Sean? I didn't see any, but you might are aware.
I did not, so we can't proceed until we find those 2 people.
So who would be kind enough to volunteer before we volunteer someone? Team? So we have someone in the queue, and we have 2 people in the queue. Sean, do you know how to handle the queue? Or people can just go ahead and speak. Team, do you want to speak?
Yeah, okay, that's good. Yeah, no, I can take notes if somebody tells me where to take notes.
I was looking for that link right now.
You have a note-taking tool, which should be the top, the 4th.
Okay, yeah. So if I open that in another window.
I'll drop it in the chat right. Oh, that's the wrong thing.
Okay, I have something, Codimid.
Yep.
Does that sound right? Okay, cool. I can
right
attempt
there.
that. Yeah.
Fantastic. Thank you very much.
Mike, you wanted to say something?
My mic. There we go. Yeah, I can act as Jaber scribe.
Fantastic. So we have our two slots filled, and we can proceed. There will be no blue sheet. Mitico is taking care of that automatically for us. Thank you. I will let Sean start maybe on the status, what's in and out of scope, and the action taken from the charter discussion itself.
Yeah, hi. You'll note that the insert graphic here, I wasn't witty enough when I was making these slides to come up with a cute wish graphic to put on the right. So next time we'll get on that. More importantly, what's in and out of scope. Basically, this is a kind of a narrowly scoped working group, and there's only a couple of things that we are chartered to do. Something that's simple, extensible, HTTPS based, and it's a signaling protocol. But the plan is to establish a one-way WebRTC session between broadcasting tools and a real-time media broadcast network. And that's about it. We're going to try to stay very tightly focused. We're not trying to, change SDP. We're not trying to, change HTTPS or any of that other stuff. We're trying to stay on point with this. So when we have anything that we're going to adopt or work on, we're going to try to make sure that we stay within scope. I know that some of you want to make sure that stays the case. So I'm hoping that you'll help us do that, and that's kind of the simple plan. And hopefully we can stick to it. And then from dispatch, the basic idea was that, I think this is right. Yeah, then we need some extensibility is something that Jonathan Lennox has highlighted during the work in progress discussions at Dispatch 109. And then we can hand it over to Sergio. Unless you would like to add anything, Alex.
No, I think that's pretty clear. And maybe I want to add for the people that are not familiar with IETF that if there are some stuff they would like to do that is not in the scope, there is the RTC web group that is still open, and there is the dispatch group that is here to welcome any new request or for work like this. So it's not because it's not happening in this group that it cannot happen, but we're going to help people if that happen to go in the right direction and in the right group. Without further ado, Sergio.
Yep. And what I am going to present is just the same slides that I presented in Dispatch when we decided to create the working group. So it is just a reminder of what was proposed, and also just as a starting point for the discussion. So please, next slide. Yeah. We have a problem right now when using WebRTC for real-time streaming, and that currently there are other signaling protocols that I think that we acknowledge that WebRTC is the best media transfer for real-time streaming. I mean, it is the best one for low end-to-end delay. So while there are other protocols that are suitable for or are used today for ingest, they cannot be used with WebRTC, and that's cause that you either have to add protocol translation that add the delays, or you have to do transcoding because you don't share common codes. For example, in RTMP, you will have to do transcoding between AAC and Opus. And also you lose most of the features from WebRTC end-to-end. And also one thing that most of us want to have is that it is also working on browser. So currently the only one, there is no standard protocol that allows us to do that today. The only closest things could be XMPP, SIPs, or RTSP, but while they are not really suited for this use case. So next slide, please. So the requirements is what, yeah.
Could I ask a question just about the previous slide?
Yep.
So every one of the large streaming systems I've seen delivers video at very different bit rates to very different users. And because of that, they end up transcoding extensively on the server side, on the media distribution side before they distribute. So are you going to try and support that or avoid that? Like, I mean, the two options are if you're trying to avoid that, which I agree has latency problems, like you pointed out, then it means the client needs to deliver all the bandwidths, which is often very hard to do on the uplink. And the model for these large streaming systems, every single one of them I'm aware of today transcodes. So I'm trying to get at whether our requirement is to be able to deliver multiple bandwidths up and not transcode, or whether we're going to assume transcoding will be happening. I think that that's a pretty big architectural discussion, like decision point of what we do. So maybe we don't need to resolve it right now or anything, but I think that requirement might be a little bit more complicated. I mean, you have thoughts on that?
I think that my thoughts is that we are not going to forbid to do transcoding on the server side. I mean, because it's something that you can always do. But what we have to allow is to support to avoid by using simulcast or SVC. So as both are supported in WebRTC, I think that we just can use simulcast and SVC to support that. And for example, we are right now using it in our CDN and without any issue. So, but I'm not sure if it is.
That makes that. I mean, that makes sense as a good answer to me. I just think maybe we should make that crisp in the requirements. Then is that
Cullen, with my individual hat on, I think the scope is for signaling protocol. I don't think we assume anything on what happened with the media, whether it's simulcast or SVC at the source or transcoding later. I think the scope, even if it's listed here as one of the reasons why you want a signaling, so you don't have two different protocols that would force you into transcoding, the scope of the document is a signaling protocol. We don't speak about media so much.
Sure, but you just said the requirement is the signaling support simulcast and multicast, or simulcast and SVC. And to my knowledge, there is not yet actually an IETF specification for that fully does that. I agree. I think that's the right requirement. But I'm just saying, like it is a very specific requirement you have in mind, and I'm not sure everyone has the same requirement in mind. You might want to be clear that your requirement is for signaling that this has to support simulcast and scalable codecs.
But simulcast and SVC is already supported both in WebRTC in signaling with STP of an answer.
And which IETF spec do they both implement?
I don't know, but
exactly. My statement wasn't that people don't do this. Thousands of different people do this different ways. What my statement is IETF does not have an agreement on that yet. So just keep that in mind.
Okay. So next slide.
I think Harold jumped in the queue too.
I think Harold has a question. Harold, if it's related to the thread Cullen started, do you want to go ahead?
I just wanted to point out that we just published a bunch of RFCs that lay out simulcast in some details. For SVC, not so much, but for simulcast, we got it covered.
I think we can continue this discussion on the mailing list. But I think Cullen has a point, and I think there's a lot of things that came out from cluster 238 not very long ago. It may be a good time to clarify. I think it's a good clarification point. I will take it as an action item to relay it on the list after the meeting. Would that satisfy you, Cullen?
Oh, for sure. Yeah. No, look, I'm not. I'm just. The only point I sort of stopped us on the requirements is I think we actually have agreement on what the architecture is in much more detail than these requirements are. That like if we all agree on this point that like we're going to avoid transcoding and we're going to do that by using simulcast or scalable video codecs, that's a huge move forward in nailing down what we need to do in this working group and really narrows the solution space. And I suspect it's clearly what you're thinking, what Alex is thinking. I'm trying to like write down requirements that help narrow down the solution space we need to explore so we can get to a solution faster, right?
Sorry, Harold, you're still in the list, and then we have Adam. So Harold is not in the list, and now we have Adam. You should be able to go ahead and grab the mic. We can see you, but
Sorry, me echo issues.
Here you go.
Thank you. I don't want to over-rotate on this particular issue. We almost sounded like we landed on a spot where like simulcast and SVC was mandatory in ingest, And I don't think that's necessarily what we want in this case. Although I do agree this is probably something that we need to nail down in the spec. So taking it on as a requirement to like clarify this is good, but I don't want to come out of this thinking that we've like chosen a specific direction.
Noted. For clarification on the mailing list.
Okay, so this was the original requirements, because and some of them has been already challenged, so and changed. So the first one that it has to be easy to use. For example, as easy as we have, as RTMP is able to use it with just a URL. We only need to support unidirectional flows. It was also asked what was the use case. That the use case is as an encoder publishing to a server. So one of the original assumptions is that the server was assumed to be publicly reachable for the encoder or the broadcaster, but Adam has and other people think that it would be also good to support having the media servers behind in that environments without by supporting the ICE candidates, and it should be something easy to support. So I just leave it here, but will probably change. There is no really need for support for renegotiation, but also again, people think that maybe ICE restarts should be supported. It has to be compatible with WebRTC and RTC web specs. So, for example, with regards to simulcast on SBC, we have to implement what they support, and we cannot create new specs for that. Must support authentication and should be both be able to implement it in browsers and in native encoders. And the idea is to lower the requirement and the implementation costs for supporting in both in hardware encoders and broadcasting, by supporting the less amount of optionalities that will make it hard to implement and interoperate, because the idea is that there is a broad range of encoders and both hardware and software that are available. So we will have to limit all the interoperability tests that we have to do to make it work between all the encoders and all the servers. And the last one is that it has to support load balances and redirection that it is needed to support or to reach a large scale in CDNs. So next slide, please. There is someone in the queue. We can hear you.
Now?
Yep. It's coming, yep.
Okay, so I would just like to mention about ICE restarts. So I have some experience with university networks in Europe, and our experience with university networks was that ICE restarts are absolutely necessary because the nets change your ports, change your IP addresses or your ports. So I really think that ICE restarts should be one of the requirements.
I think there is a discussion a little bit later on the ICE part as well by Adam. I'm noting your point, Julius, and if there is no discussion today, we're going to bring it to the mailing list anyway, to make sure that this point is discussed by everybody and give it given time.
Okay, so the original idea was to just make a simple HTTP post URL, and that it is the URL of the web endpoint, and to do an SDP offer answer in the post request that will allow us to set up ICE and then the DTLS and RTP. So originally I was proposing that ICE context freshness was used for detect disconnection, and also DTLS tear down to signal the normal disconnection from the session. It was also Adam and Lorenzo thinks that it will and most people and other people think that it will be good to have more commands to be able to terminate the session explicitly, because DTLS can be lost and not to have to wait for the ICE timeout before being able to terminate the session. The authentication authorization is done via a standard HTTP header request. Both, and I was proposing to use the authorization header, but some people also think that it would be also good to have digest authentication via username and password. But as long as it is supported by HTTP, I think that we can support both. And this will also support redirections and load balancing by just returning the different redirection response from the with endpoint to you could have a URL for an entry point, and this will be able to redirect you to the final with endpoint. Yes, Adam?
The discussion around, sorry?
Go.
I just want to make sure the discussion around the different authentication methods, I think I may have been the one who initiated that. And after looking at it a little bit more, I don't think we have that requirement anymore. So I just wanted to throw this out there to see if anyone else had thoughts on that. If it was just us, then I think we can probably retract that as a requirement.
So Adam, do you have that in your slide for discussion later or not?
No, I didn't address this directly. When I put my list of things that I thought we needed to add to the spec, I just left this out.
Okay, so we have 40 minutes at the end of the agenda that is not taken by anybody. I know authentication is something that a lot of people want to speak about. What about we keep that for specific discussion after your slides and Lorenzo's slide? Does that work?
That sounds good. Thanks.
Caroline, I see you taking a slot in the queue. If it's about authentication, do you want to delay it until a little bit later in the meeting?
No, it's a question about ICE. Do we have a good space later in the meeting to discuss just our overall view, like ICE and requirements and what we might do better or worse here? Like I'm perfectly happy to discuss at a better time.
We have a full 40 minutes at the end for things that are not in the agenda already. So if you think it's going to be a long discussion,
we discuss there like why we really think we need ICE and what our alternatives are for that area, because or what are the restrictions on how we'll use ICE, something in that space, because right now ICE is one of the largest failure points of WebRTC, and I think that we could make it much better at this point.
Well, I can already respond at the chair, right? We want to be backward compatible with WebRTC and WebRTC mandate ICE to a certain extent. So we won't be able to completely remove it in a way that will not be compliant, but the discussion between do we support ICE Lite or full ICE or trickle ICE and things like that is in the scope. So what I propose is I put a second point after authentication in that 40 minutes period at the end of the meeting for a longer discussion.
Okay.
All right.
Look, just a minute here. You just said something that's wrong too. You said we have to be fully backwards compatible with WebRTC. That is not in our charter and is not true. I mean, I agree with you, but obviously we do need to do things, but what you just said is not actually true, right?
I believe it is. I can revisit that
let's just
point.
be really clear. Like full-blown SRPV and simulcast, which you've already required this morning, is not part of WebRTC 1.0 fully, and you're probably not going to do it exactly that way, right? Like I'll go reread the charter, but I don't think that was quite right.
Let's revisit that.
Okay.
All right.
Anyway,
so
I'm glad to discuss exactly what you said about ICE is great. Let's have some time to discuss that later. That sounds good.
Okay, we have people in the queue. Let's flush the queue. Adam.
So I did want to address both the charter issue and the notion of what constitutes WebRTC here. The charter does say we're going to use WebRTC as a basis, and right now, if you read through even the base specifications, ICE is absolutely a requirement for getting things set up. You can add on optionalities, things like the simulcast, but I don't think the discussion of whether we're going to use ICE is in scope here.
Okay.
What I said,
Harold?
but that this has to be what WebRTC 1.0 is the only thing we can use, and that's it, and there's no change to that. That is not that's in the charter, right? That's my only thing. The thing that was actually raised of like, hey, isolate, single IPs, all those things is exactly the discussion I want to have. Like, this was not a discussion I'm trying to kill ICE. The discussion when we talk about how we use ICE to dramatically.
I understand, Colin. You want to the scope about how we use ICE to be a little bit more.
Right?
You want more clarity and accuracy on that. Is that correct, Colin?
This has already taken more time than is worth. I'm just saying, let's not start with
because
the
you're
assumption
speaking.
that there are no extensions possible to WebRTC in this work, because we're not going to manage to do it that way. Like that's very unlikely given what we want to do.
Right. We're not looking for extensions here. We're just looking for no omissions, right? You're asking to omit what is fundamentally a core feature of WebRTC session startup.
I did not ask to remove ICE. I asked if we
Okay.
could discuss time to discuss ICE, right? And what I want to discuss is exactly all the things Alex rightfully raised of like, hey, can we assume that the far end has a public IP address, for example? Could we, that dramatically changes what you need to do ICE. And no, I do not believe that this work should require that the endpoint on the full side implements full-blown ICE necessarily. Okay, I understand the web browsers will do that, but they're not the only thing in the world. In fact, they're the least likely thing to be streaming media to many of these things. They're generally done by apps, right?
I don't think there is a big disagreement here, actually. Let's keep it for a little bit later. Harold?
Yeah. If it interoperates with browsers, it might be a success. If it's not interoperating with browsers, it will probably be a failure. So interoperate with browsers, yes. Be a browser, no.
Okay, that's fine. Julius?
Yeah, so I would like a clarification about the charter. So are we assuming here that everything, so the stock seems to imply that signaling goes over some sort of RESTful interface, or perhaps something that resembles SIP. And I have the impression that much of the WebRTC client-server community has standardized on using WebSockets. Is signaling over WebSockets something that has already been decided to be out, or it's something that is still under consideration?
So wait, Julius. Sean, can you go back to the scope slide, please? So the scope of the charter is the signaling protocol. It's one way, with most of the time the destination not being a browser, so it fits what Harold's comment was addressing. It's WebRTC based, right? So that means we need to use JSEP, for example. So in all the specification we have at IETF for JSEP, there is no specification for the signaling transport protocol. JSEP is the signaling format and the handshake and SDP operator.
Yeah.
And so until today, everybody could use whatever they wanted, and that included XMPP, SIP, WebSocket, whatever you want, but it was not standardized. So the idea here of the scope of this group is to say, in the specific use case of a one-way WebRTC base between something and a network, right, and a platform, where we can make some assumption about IP, we're gonna define an HTTP-based simple signaling protocol.
So this excludes WebSocket, right?
Yes.
Okay, WebSocket here is not considered as being part of the HTTP stack. When you say HTTP, you're speaking about GET, POST, and traditional HTTP.
That's my understanding of the charter, yes.
Okay, thank you.
Adam? And in and out.
So I just wanted to address, so Julius, you are correct that like when you're talking about regular web applications talking to themselves internally, that WebSockets is fairly popular here. As a practical matter for the proprietary clients that have been put out in this space, in active production, by and large, they're using RESTful interfaces. So in terms of what fits best with the currently deployed architectures, the rest is probably a better fit.
Okay, last one, and I will let Sergio finish his slide to stay on time. We have 4 more minutes. Mike?
I wanted to respond to that. I think that the idea that we should consider WebSockets is worth at least a little bit more consideration. So far, the discussion on the list has seemed to be about simplifying the implementation on the encoder side and keeping that kind of minimal. But if you're already implementing all of these other things for the media flow, you already have much more complexity than WebSockets brings to the table. So the benefit would be that we don't have to invent new semantics to layer on top of HTTP semantics going back and forth. So some of the things that we've discussed about commands and how to manage the session, using a heartbeat as a chance to respond or send a message from the server to the client. That is all simplified by using kind of the existing de facto WebSockets approach. So I think that we should be at least carefully consider our reasons for ruling that out and maybe articulate them.
Noted. Sergio, you want to finish your original slides from this batch?
Yeah, yeah. And I was going to comment that I agree with Mike that I think that REST is good, and if we keep doing like simple requests, but if we start to introduce long polling and things like that, I also will be more likely to move to a WebSocket in the API that introduces long polling. But I think that Adam will talk about this in his slide, so we can keep the discussion for later. And I think that it was the last one, my last slide.
Great, thank you, Sergio. We were a little bit ahead, and in a long IETF tradition, we ate all the time we had gained. Next will be Adam. There will be a lot of interesting content, so let's get ready for discussion. It's supposedly 20 minutes, but I'm going to put a 30-minute counter, just in the spirit of controlling the time. All right.
Thanks.
Sean, you have the slide on screen? Fighting with Mythical.
I hope so.
Here we go.
All right, cool.
All right, so I'm coming through, right? You can hear me?
Yes.
All right, perfect. So I sat down and looked through what the things were that I believe we need for this kind of ingest protocol and compared it against what we had in the initial proposal, and came up with a handful of things in combination with the comments that were made during dispatch that I think we would want to add to the WISH, to WIP, the WIP proposal. And this is kind of the list of areas for conversation. The first, and this came up in dispatch, was the desire to have some sort of session management, and specifically a way to signal termination of a session. The need for extensibility was put out there, as well as and on top of that, some of the stuff that we've realized that we needed from a signaling layer is the ability to have heart beating to determine at a signaling layer whether a session was still alive. And this is kind of based on a separation of concerns where you have signaling on one layer, media on a different, and a signaling protocol in the network itself that talks between them, which is a fairly common way to decompose these sorts of things for scalability. We also would ideally want the ability to have two-way communication, largely casting back the ability to have termination initiated by the network, but possibly other network operations in the future as well. We ideally would have ice management, and Julius touched on this also, where there are sometimes cases where we're going to need to be able to do restarts, and sometimes you're going to want to do trickling. Now we're going to touch on this when we get to the, I have some slides specifically on why we might need more ice operations than is immediately obvious. And we also probably need to have either a specific specification of which media types and how many are going to be sent, or a means of negotiating that. And I'll touch on all of these in future slides. So go ahead and go to the next one. I wanted to highlight some of the constraints that we basically taken on with our charter when we agreed to use HTTP as our basis. There are a couple of best current practice documents out there. The first of which is BCP 56 that talks about how applications can use HTTP as a substrate, and the other one is BCP 190, which talks about how applications can use HTTP URLs. And I bring these up mostly because when I was going through ways that one might solve for these requirements, there were some kind of easy and obvious solutions that ran aground some of the constraints that are put on us by these documents. So the most notable restrictions that we probably need to keep in mind as we turn over various solutions in our head is that we can't define any new HTTP methods, headers, or responses unless they have some impact on HTTP processing itself. So that means that we can't put some sort of like wish-operation header field that indicates what we're trying to do. We have to use any existing methods that we use to mean what HTTP defines them to mean. So this is why, for example, we don't want to use options to mean ping, because options has a specific meaning and it's not that. And then finally, we can't define rules for building HTTP URLs. We can't like send a base path and then say, and then you add these things onto the end of it in this formulaic way. Next slide. Okay, so the first thing that we probably want to nail down is how we want to do session management in general. This is kind of a sort of the base. How does the protocol work? There were a couple of options that have basically been banding around in the mailing list. The first, and this is very similar to the current proposal, is where you would send a post operation to a URL that represents sort of a session creation endpoint, and then get back a 201 created response with the location header field that points to a newly created resource, and that resource represents the session. And then in terms of when you tear that down, what you could do is you could send an HTTP delete that means delete this resource. That's a very good semantic match. Or we could have basically session termination by whatever means we do other operations for a certain level of consistency. The second approach here would be to send a post to that session creation URL and get an OK back, where the body contains in some way a list of URLs that tells you how to perform the various operations that the server itself supports. And one of the things that's kind of nice about this approach is that while the post 201, just the way that HTTP has defined that, can't contain a body in the answer, so you can't do anything else really. If you were to use just a post 200 exchange, you could send an offer in that post and get an answer in the OK, and basically save a round trip of time as you're setting up one of these sessions. So I want to pause here and see like what the feel of folks here is around which of these basically three paths we might want to take forward. And I'm leaving it to the chairs to call on folks.
Yeah, Callum, you can go ahead if you want first, and then the author.
Adam, it just seems like we've got a lot of experience with doing REST APIs to send an offer answer up. There's lots of languages for defining, various API description languages. They're supported by API gateways and all of those things. And I just think that we would probably want to go with a very common practice way of doing this. I do think doing an offer answer and round trip should be one of our requirements. I don't really agree with your statement that URLs are often built in REST APIs by extending by knowing the parameters that come after some base origin URL. So I think
I wasn't saying that was common. I was saying that is an approach that presents itself that we can't pursue. That's just something 190 says we can't do, because BCP 190 says we cannot do that.
I think Martin and Ham have discussed extensively BCP 990 says that. And either way, I don't care. I think we should do this the way APIs are largely done on the internet today, regardless of whether BCP 190 says whatever. I think we should do what works well. I mean, any reason not to do that, right? I mean, look, it's like you know how every API works on the web today very well, better than I do.
So Conan, do I
follow that approach?
Conan, do I understand correctly? And you volunteering to propose something?
Sure, I will be happy to send you a blueprint or a Swagger definition of that, which will be like about 5 lines. And like, that's actually what I think our spec for this whole working group should more or less be, right? Like IETF just manages to wrap itself into tangles of not doing what works well on the web. Like, let's do something simple and pragmatic and is proven to work well today. We all know how to do this.
To be clear, the notion of sending back a map from operations to URLs, that's not uncommon either, right? That is something that is fairly well exercised.
It's gratuitous complexity and gratuitous extra round trips. It adds no value in any form.
I propose that we take that decision.
It's not common.
In the spirit of time and the absence of distribution and statistics of APIs across the entire web. Sergio?
Yeah, I think that obviously I have a favorite between these options, but I think that it will also depends which options do we want to add to the basic negotiation, because if we don't want to add anything, I think that the best is the good option. But if we need to do a lot of operation, then we will have to do more complex stuff. So I think that I will prefer to leave this at the end, because I think that the delete operation will be just one of many operations. So I think that when we decide how we do the other operation, this one will be natural.
Okay, so you would like to see the list of all the operations before you decide how to do.
Yeah, I mean, because probably the one that I choose is not the best one if we decide to do a lot of things.
Okay, Timothy?
Yeah, I think this I kind of agree with Sergio, and I think it may also hang on how load balancing looks. I think these two options are different for different load balancing techniques. If somebody could stick, yeah, okay, cool. I'll try and note myself there.
Okay, back to you, Adam.
All right, so it sounds like we're going to circle back to this then. Next slide. Right, so actually I covered these just orally. Let's go ahead and go forward. So I also wanted to add a slide, since it sort of came up on the list. I don't think we're quite to the point that we want to have a discussion around session management syntax until we have an agreement in principle about which session management approach we're going to use here. So next slide. So the next topic here is how we're going to have extensibility in general, and there are a couple of different dimensions for extensibility. What I would propose is that we have the WISH document here defining a core set of functions that clients and servers need to implement, and that just in principle, implementing these base functions needs to always be sufficient to initiate a broadcast. And that we want, on top of that, extension points for adding new operations to enhance functionality, and as a separate concern, extension points for adding new parameters to existing operations. And the way that we're going to achieve interoperability with this sort of scheme would be that the clients and servers can always ignore unknown or unsupported operations while still functioning correctly. The analogy that I think I put out on the mailing list here is one with the way that SIP works, which is that, for example, a base SIP terminal can dial into a conference bridge and have things work just fine for the person dialing in. They're going to miss out on enhanced conference-related functionality. And then we have other things we've added on to SIP that allows the participant to like do floor control and to see who's in the conference and that sort of thing. But those aren't necessary to participate. They're just enhancements. So the proposal here is that any sort of thing that we would ever add on to WISH as an extension would be just that, not necessary to participate, but something that would make the experience enhanced in some way. And again, I'm looking to see if anyone's in the queue. I don't see anyone, so I'm going to go on. Go ahead.
No, nobody in the queue.
Thanks. I mentioned this up at the top around heart beating. There are certain decompositions of networks that makes it easier and cleaner and less resource intensive if you've separated concerns between a signaling plane and a media plane, and then are able to determine liveness independently of the signaling plane of the media plane. So one of the things that we propose is that we would have a simple heart beating mechanism. Just whatever thing we use for operations would include heartbeat as an operation. And that the client would be expected to perform just a very simple, as small as possible operation against the session endpoint. And there are some things we want to nail down here, like how we determine what the period for heartbeats are. Like we could have a hard-coded thing, or we could have something where the server indicates to the client which heartbeat interval it expects, or even a negotiation, although that seems to be getting a little bit too baroque. So let's go to the queue.
So Adam, we have two people in the queue, Sergio and Tib. Sergio?
Yeah, regarding heartbeats, yes. First thing is that this only makes sense if you have a different components for the signaling from the media server. If you have all in the same component, it does not make sense. But and I have also to look at this because we have had situation when we are clearing down session because the signaling is disrupted, but the media is flowing perfectly because you have different paths, and I'm not sure if it is something that I want to implement. I mean, it's because we are having a situation in which we are terminating sessions because the signaling path is not working properly, but the media is perfect, and we are tearing down the media session when it was not. It should have not been teared down.
I'm going to wait, Adam. There was Mike before that say if we want to have an heartbeat and so on, then why not going to WebSocket? So that bears two questions. One, what is the use case? What is the necessity of a heartbeat exactly? And two, if wouldn't be WebSocket then better in that case? Before we go to Timothy in the queue.
So I'm sorry, you had a question there. Who were you addressing it to, Alex?
I was speaking to you, Adam, and I was referring the question that Mike asked before about WebSocket, saying that, for example, if we had to use an heartbeat, then we might as well use WebSocket, for example, because that would be bundled among other things, right? And that bear the question, do we really need an heartbeat? And if we do, then should we consider WebSocket?
Right. So I have to admit the notion of using WebSockets along this hadn't really occurred to me before, so I'm going to have to process that a bit before I put forth an opinion. In terms of heart beating being sufficient to push us over that threshold, probably not. But I can see between heart beating and the ability to send operations from the server, we might get there. It might make for a bit of a stronger point. In terms of needing heart beating at the signaling layer, again, there are certain architectures where the design makes this something that is far easier to deal with, if depending upon what sort of control structure you have between a signaling plane and a media plane. Such that I don't want to end up with a situation that you have to have operations necessarily initiated from the media plane to say to the signaling plane, hey, this session has gone away. It's not necessarily an absolutely hard requirement. It just makes things a little odd when you have something coming basically from a controlled plane to the controlling plane to let it know that the session has been torn down. As a matter of practice, obviously, when you have things exceptional, you're going to need that sort of operation.
Okay, thank you. Tim?
Yeah, I mean, I think you have to think about what the failure modes are that the heartbeat's trying to protect you against, and the WebRTC experience is that people really just do shut their browsers, and you want to catch that in whatever your quickest way is, and I'm not convinced that a heartbeat, and certainly at WebSocket layer, is going to do what you want. It doesn't tie closely enough to the media to be useful, in my view, but I'm probably exceptional on that.
Thank you. Julius?
So I'd like to argue in favor of heartbeats. So coming back to the academic use case, there is this common situation in which you have 100 students waiting for a lecture. And the students want to have positive confirmation at the beginning of the lecture that their connection is working fine. So if they somehow get kicked out from the network, they need to be notified of that in a timely manner, even if no media is flowing yet. On the other hand, the lecturer wants to know if, say, half of the students in your lecture theater suddenly got kicked out. So timely notification of sessions dropping is something that we have found to be extremely useful.
Sergio?
Yeah. Just talking about heartbeats, not about load pooling, because if we have load pooling, we probably need heartbeats anyway. But we need to implement a media timeout from the media server. So I don't know why we need to do this twice in the signaling plane and in the media server, because the media server already has to do ICE content freshness that will time out if no ICE is received. So you have to take that into account. And I don't see what extra value has this heartbeat to the signaling plane provide over the media heartbeat, because if the ICE is because, for example, whatever happens to your encoder and the media has stopped flowing and the ICE is stopped completely, well, you are getting heartbeats for the signaling plane, but the media is not flowing, and you must handle this situation. So you already need to support that. I'm not sure exactly what does the heartbeat over the signaling plane provides over the media heartbeat.
And there is the second problem you mentioned before that you had in production, where the signaling plane was separated from the media plane. The signaling routing will be down, but the media would be flowing. And if we had an heartbeat on the signaling plane, would be breaking down a media session that is actually working.
Yeah.
Did I take the note correctly from your previous comment?
Yeah, that's exactly the case.
So your network can decide whether it's going to tear the session down on the failure of a heartbeat, right? Or are you concerned that the client will be heart beating, somehow lose the ability to contact the server, and then tear down the media session as a consequence?
Both.
Okay.
I mean, because we have got problems with Nginx being overflowed and heartbeats just stop for several 1 minute, something like that. Then all the media session were dropped because we have a heartbeat in the signal plane, but the media was perfect. So we have all the sessions turned on because that problem in the Nginx that was not even the media plane.
Okay, so basically you're putting forth a requirement that the session should be able to survive a failure of the signaling channel.
Yeah.
If that's the case, we should probably document that as a constraint on the solution.
Yeah, I mean, in my original in my original proposal, I didn't have a signaling session established, so I didn't have to handle that use case. But I think that
So,
Right.
so Sergio,
that's
what Adam is saying is you want to explicitly write it down as one of the requirements, while it was implicitly a feature of your proposed solution before.
Yep.
Nowhere you have written, I would love the signaling session to survive in case it's broken and the media is still flowing, right?
Right. Now I just want to surface the requirement so that we can make certain that we have a conversation around it.
Could somebody
Again,
restate that requirement? Because I'm like got slightly lost in my notes.
So in my notes,
it would be
yeah. Go ahead, Adam.
The requirement would be that the media session can survive a failure of the signaling layer.
Colin?
You know, I think that part of what's causing the confusion here is maybe we're talking about a specific mechanism to support a signaling channel, but I think some of us are not 100% clear on what the signaling channel is used for after this initial setup of the call. I mean, even the buy or what, like maybe we just got our ordering a little bit wrong here of that. If we looked at, why do we need a signaling buy? Could we just use a media one? What are the other signaling mechanisms that we need? Let me call it mid-call, for lack of a better word. I know that's not the right way to phrase it, but you know what I mean by it. Once we understood what we were trying to use it for, then I think we would understand what reliability characteristics we needed of it better, and then we could discuss how a heartbeat mechanism may or may not be needed to meet those reliability characteristics. Does that make sense? It's just a way of thinking about it.
That's fair, and we get to some of the operations here, I think, in 1 or 2 slides. The one thing that I want to hold out as something to be aware of is because we might want to have new operations in the future, casting back the extensibility discussion, we have to consider this an initial set and not a closed set, right?
Yeah, totally fair.
Okay, seeing the queue empty, I guess we go on. So yeah, I guess it was 2 slides. In the future, we're going to talk about the specific operations. But in terms of two-way communications, we do minimally want the ability for the server to terminate a session. And I suppose if we're going to the prospect of using media level heartbeats, then we can use media level termination for this. I still have some pretty strong reservations about that approach. But if we assume that we're using signaling for session control here, then we want to be able to terminate a session from the server back to the client. And there are a couple of approaches that we could do here. The one is sending server to client operations in heartbeat responses. Now we're assuming under that we would have heartbeats in the first place. And there are a couple of different ways that we could do this. One would be to have the server wait for a heartbeat. And if we have a relatively frequent heartbeat cadence, then this isn't that big of a deal in terms of having to have the server have to wait up to, again, if we use, say, 15 seconds as a straw man here, wait up to 15 seconds to be able to send an operation to the client. That's not terrible. And the other approach that we discussed briefly on the list is having some kind of long pole for the heartbeats where the client would send a heartbeat and then wait on the
Just lost Adam's audio, which makes note-taking tricky.
Yeah, I think he's on his way back in. We can see your lips moving, Adam, but we can't hear you.
There we go. Am I back on?
Yes.
Can you hear me, Sean? Okay, good.
Yeah.
Yeah, Meet Echo just told me that disconnected, reconnected my audio. I apologize. Where was I when that cut out?
Don't worry, the slides were gone from the chair as well, so you're good.
Had just explained, you'd said the words long pole, and you were just sort of explaining these various approaches is where we totally lost you.
Okay, good. So I got through most of that then. The other approach would be to have effectively a long pole where the heartbeat transaction would pend basically for the duration of the heartbeat, and then the server would respond with either a 200 to the heartbeat, and the client would turn around and initiate another one right away. Or if the server wanted to send an operation, it could send that response earlier in the cycle so as to get the operation to the client as soon as possible. The other approach, and this sort of ties back to what Mike was saying, is that we could have a persistent channel set up, like a WebSocket or a data channel or something, that we could send these operations back to the client on. And I know we should have a queue now.
Yes, we do. The usual suspect column.
I mean, I think it's sort of been mentioned by other people, but I don't, if we need these types of things, I think that, like, if we need mid-call signaling initiated from the server to the client for notification of things, it's very unlikely that a 15-second delay is going to be okay from an extensibility model for the type of stuff you'd want to do that. I'm not sure we need it at all, but like, really, this looks like this looks like one of the hackiest, worst ways to do notifications to clients I can imagine. I think we should use something architectural a little cleaner if we decide there's a need for this. And we don't need to discuss it. Just sort of file like, hey, opinions vary, whatever. But I think as we come clear what we need, it's fair to do it. And I mean, data channel. I mean, it seems like we have lots of options available. I mean, it seems like there's better ways to skin this cat, but we're discussing about the exact details of how to move the bits on the wire when really we should be discussing the semantics of what information we need to flow between the server and the client.
Okay, so that's an ordering comment effectively there. Okay, so we can return to this then after we have a better notion of exactly what it is that we want to accomplish. We have Mike in the queue.
Oh, Mike.
I just wanted to kind of echo Colin's comment that I think we have some semantics questions to grapple with before we get into the implementation details of bits on a wire. Kind of outlining the participants and some of these different constraints that we've talked about. It may be worth kind of surveying the status quo of, what does a browser-based ingest session look like today? And then how do we envision, the participants of a non-browser based session having different constraints, and that would necessitate changes from, what's done today.
So do you want to comment on what those constraints might be?
I mean, sorry, I may have lost my audio. I guess one of the big ones is, why not WebSockets, right? Like, it's come up before that, we think we can, get away from this complexity, but if we have need for session management and this two-way communication, we're going to want some kind of persistent channel. So I think there's two things then. One would be, new constraints that come from this different environment, which is, encoders that are not browser based. And two would be assumptions that we could make about this context where we can cull some complexity. So things like, trimming down what we need ICE to do. If we can assume that the server side has public IP, I think we can also, say similar things like if we assume that an encoder is only doing this, we may be able to remove some complexity there. So, but I think that's maybe the level of the discussion that we need to have before we get into whether or not WebSockets or data channels or long polling or whatever actually makes sense.
Okay, all right.
Tim?
Yeah, I think we need to think about who the audience is for this. Like, one of the things that isn't in the charter and maybe should be is the explicit goal from my point of view is that, like, somebody who is building a web service at the moment that is happily using like RTMP should be happy to pick this up and shouldn't get the, oh God, it's WebRTC, I don't want to touch it feeling. And you can like frown at that, but it's a real perception you'll get from a ton of web developers. So the less like WebRTC this looks, the more likely they will sign up for it. And I think it's kind of hard to put that in the charter, but I really think that should be a goal here.
Sean, can you put back the charter slide, please? The scope? So the scope of the working group is a signaling protocol for WebRTC-based audiovisual session. Right, so and we said at the beginning with Sean, we do not want to reinvent WebRTC or to strip it down. So Cullen make a good point. We might want to go into the WebRTC spec and define a little bit better what we want. But one of the things we absolutely do not want is to challenge ICE, to challenge ASEP, to challenge SDP offer answer as a way to negotiate the media type and the encoder and the decoder and things like that. Otherwise, we go down that WebRTC. We want to be able to navigate between possibly the optionality of WebRTC, like we have a different IETF document for the non-browser, for the gateway, that explain how ICE is different in that case for the implementation. So I think we all agree that we need to go a little bit deeper into what we mean, but big fundamental change to the core of WebRTC will definitely not be in scope explicitly.
Sorry, if I gave that impression, that wasn't what I meant. It is obviously going to be WebRTC based, and I don't want to say anything different there. But what I do want to say is that a web developer who picks it up shouldn't be smacked in the face with a huge ton of WebRTC-ness. And there's a distinction there, so that the more we can cover up the WebRTC-ness and the more we can make it invisible, the more adoption we'll get. And I think that's what I'm trying to say. There's a goal there.
Can you make that concrete? Like, how would that bear on our decision-making process here?
So I think the moment you have a side channel that can do stuff, then you've strayed away from the RTMP model where, like, you set it up and it keeps running. And so if the side channel the signaling channel is required, then you've strayed away from the RTMP layer. When you look at RTSP and RTMP and things like that, you set it up, you fire it up, and once it's going, it goes, or it dies. But that's like, there's not a great deal else that happens. And I think sticking with that model would make people's life easier.
Okay, thanks.
Sergio's in the queue as well. Sorry.
Okay. I agree with Tim in that we should not over-engineer things. I mean, we are IETF and we like to do that, but I think that people is happy implementing RTMP, and the functionality that RTMP is very limited. And I've struggled to think that we should implement much more than what RTMP does to cover the same use case that they are doing. I mean, if we can add things that add no complexity and add value, we should definitely go for it. But I'm reluctant to implement stuff that it is not really proven to be a must, because each feature that we add, even after optional to the spec, is going to be less likely that it is going to be implemented, for example, in FFmpeg.
Mike?
Mike, you're in your queue?
Yes. So I think what Timothy is trying to articulate is RTMP not necessarily as a complete set of functionality that we need to emulate here, but more as an example of the type of use case that we're going to be attempting to translate onto WebRTC, because we have some benefits from using WebRTC rather than RTMP. And so if we can kind of like articulate, like today, for example, we do WebRTC broadcast out to end users, but the majority of our ingest is RTMP. And so we have, overhead from all the transcoding associated with, taking in RTMP and, outputting over WebRTC. And in cases where we can run WebRTC natively end to end, everything's a lot cleaner. But we can't just point FFmpeg at our ingest and say do WebRTC. Here's your WebRTC URI. It's a lot simpler for RTMP, on the encoder side. So I think what we want to do is stay focused on that use case and say, we want it to kind of basically work, the way that you can just point FFmpeg or whatever your encoder is at an RTMP endpoint and go. We want to be able to do that with WebRTC and not have to require getting a whole browser involved just to send AV content.
Julius, you're next in the queue. And first, I'm sorry, I'd like to ask you a clarification. You spoke about your academic teaching use case before, but this is a video conferencing use case, right? This is a many-to-many. And we're not hearing you yet.
I was thinking of a lecture case, which is one person speaking to 120 students, and students asking questions usually in written form, which is what we have been doing during COVID lockdowns.
Okay, so that's media one way, and you have a feedback loop through chat.
So
text, right?
It's somewhere in between.
Okay, fair enough. You want to share your screen, you said?
No, I wanted to, sorry, no, that's a mistake. I wanted to ask one question, which is, so I'm starting to understand Sergio's point about simplifying the protocol and not having a control channel or minimizing it. I'm slowly starting to understand that one thing I'm not expecting an answer now, but that's something we should think about. If we reduce the protocol in the way that Sergio seems to envision, I'm not sure I'm getting it quite yet, but in that way, we need to think, what's the added value with respect to MPEG-Dash? MPEG-Dash works very well. It does broadcasting. And so if we are doing this, shoot and go, just streaming the media without a control channel, does there remain anything we can do much better than MPEG-Dash?
Well, the signaling will be maybe similar, but the media stack will be completely different, right? So MPEG-Dash doesn't have any feedback mechanism, doesn't have all the RTCP control and so on that RTP and WebRTC has. So there are quite some difference at the media protocol level. Here we're only speaking about the signaling, right?
So the question is a WebRTC-based stack, does it bring any added value with respect to MPEG- if we no longer have ICE restarts, if we no longer have session control, and so on? I'm not saying it doesn't.
My gut feeling is yes, but there will be a lot of opinion. I propose we ask that question on the mailing list, so everybody can contribute. And I think that, is that okay with you, Julius?
Sure.
Mike?
I just wanted to respond directly to the question of why not MPEG-, and it's for us, it's simply latency. MPEG- or HLS are good options for relatively low latency, but there are use cases that require lower latency than that, and that's where we require something like either RTMP or WebRTC. So that's our use case.
Julius, you back?
I think he may have just left himself in the queue by accident.
All right. Yep. And he's out.
Okay. All right. So let's go on to the next slide then. Okay, so ICE management, and this is probably going to have some lively conversation around it. So one of the things that I have a concern around is that it's possible that we could reach a future state where IPv6 clients are going to require even ingest gateways to be behind NATs. If we don't end up with pretty much universal IPv6 deployment before we have address exhaustion sufficient to impact like server deployments, right? So it's easy to imagine that you have sort of a first contact point, a signaling contact point that has a public IP address, and then a large bank of like a scalable CDN behind that is actually behind NATs. And if you ever end up in that situation, we do need to have the ability, either with a base protocol or with some set of extensions, to have the ability to have like a full ICE implementation with trickle and with restarts. Now, with a sufficiently rich extension mechanism, this isn't really an issue, but it does kind of violate the principle that I mentioned at the top of my discussion, which is that we do want the base protocol to always be sufficient to start up a session. In terms of the additional complexity that it introduces, as long as we have like operations that we can send inside a session, this is pretty minimal because ICE and trickle ICE are already part of JSEP. So assuming that people haven't like gone off and implemented WebRTC from the ground up and are using like one of the available libraries, this is already going to be included, right? Trickle ICE and ICE restart are going to be part of what's in the WebRTC stack that you take on. And from that perspective, adding them to WIP isn't going to be particularly complex. That said, because it's not really necessary right now, I'm personally kind of on the bubble as to whether this is something that we need as base functionality or something we can simply leave for the ability of future extensions. So let's go to the queue.
Colin?
So this is one of those areas I think we've had a lot of, like, the internet is littered with like jokes about like you try to use WebRTC, then you find out you need a turn server, you can't find a turn server, and then you give up and go do something else. I mean, like, this has been one of the really hard points for people to deal with. So let's talk about the case where I have a bunch of where I don't have a lot of IPv4 addresses for my servers, but I have some. And AWS is natting my servers behind on the server side, okay? The way that's done is there still will be a port allocated and IP to the load balancer, and then the load balancer will span that out to multiple machines. But I will know my IP and port that is the thing I advertise. I'll know that ahead of time on the server side, even if I am being natted with v4 addresses on the server side. I'll know it will be the type. It'll be a full cone style NAT. It will be things to be able to come in there. Clearly, the clients will be behind NATs all the time. But it seems like if we mandate that the server must be able to advertise an IP address and port that it's publicly reachable at, or one of its nodes in its cluster is publicly reachable at, and first of all, the server would only have to implement ICE Lite, which dramatically improves the performance and speed of the high speed servers. We could get to a place where it was really easy for the client to know in a round trip that we could say something like, you're doing ICE, but the client never provides anything other than its reflexive candidate. And that goes up in the offer. And then coming down in the answer comes the server's thing. And you don't need trickle ICE. In a single round trip, you can fill your offers and answers with the actual IPs in use. You don't have to deal with any of the trickle things. You don't have to you will never need a turn server. You will, we can very much pare this down to something that's not only easier to write and deploy and is still a subset of ICE, is still doing valid ICE, but is also much easier to debug. And that's really my main concern, is the much easier to debug part, because that's one of the things where ICE goes very sideways. Do you see any problems with, does that vision of constraining it in that way limit anything that you're talking about here, or would that work?
So let me answer that after I ask, make a clarification and ask a question. So the clarification is that if we were to go down this path, it wouldn't necessitate that servers do anything other than ICE Lite, unless they end up in an architecture that requires them to do something more complex, right? So this still allows servers to do ICE Lite when their deployment supports it. Right?
Sure. What I'm saying is that the WISH protocol could say that the offer answers that we didn't have to, that basically the WISH servers needed to be deployed in the type of environment where ICE Lite was possible, and that greatly simplified the number of round trips of signaling we needed to do to start up something.
Perhaps.
And we might choose much faster timeouts. We might have much speedier setup than you would do if you did full-blown ICE. There's all kinds of advantages of this.
Okay, so that last part I'm not quite happy with, because I want us to be able to do this from browsers still, right? So things that are baked into the browsers in terms of timing are going to still be there. Sorry,
no. What improves your speed in ICE is having less possibilities to test. I wasn't talking about changing the timers in the current ICE code of the browser. So I misphrased that. That's right.
And that gets to the question that I had, which was,
you're only going to have one candidate from the other side, and it's going to work. Like, that's it, right?
So what is that one candidate you envision? What is the client going to send in that case? That's what you said something, you went a little fast past, and the client will send only that one candidate. Which candidate are you talking about?
It's reflexive candidate. So it will do stun. It will find its public IP address. All right. Then only that, and it will send that in the offer, not send it later. It will get that before it sends the offer, send it, and then it'll get back the answer and the answer. Because anything else will not result in media starting any sooner, right? You're not going to get media until you have that address. And sending an initial one allows it to even be primed so that the first packet come from the server arrives. Like, it ends up in an incredibly simple flow, simple to debug. You know exactly how the packets are all going to flow every single time. And I'm not saying it from the client point of view, it is doing 100% ICE. It's just from how we use ICE at the offer, answer, and trickle and stuff. It's all the same. And I haven't touched restart. I want to talk about restart when we get to that. But I'm glad
we have 4 people in the list, so I'm going to go through the queue, but I'm not closing that subject, so you will have an opportunity to come back. Perfect. I'm worried about clients that would be in a bank or in a network where the reflex candidates are impossible and we still need a turn server. I don't think we're going to be able to bite that bullet on the sending side, on the client side, but we can have that discussion.
I'm not understanding the use case. Thinking of that doesn't make sense to me. Say that again.
There are some. WISH is a one-way, right? WIP is a one-way, and so on the sender side, it could be within a bank or within a network that requires a turn to actually go out and traverse the NAT. A restricted NAT, restricted firewall, restricted port, need to go over TCP 3443. So,
well, I mean, a restricted NAT or a restricted firewall would not require turn in this use case. With the server IP address is look, if it can't reach this this server address that's public, it's not going to be able to reach the turn server either. So turn does not help in the case you're describing.
okay, let's go to Tim in the queue.
Okay.
I was interested in that as well. I think turn TLS is a question. Do we have use cases which will require the support turn TLS? And I think that the benefits that we're talking about here over RTMP and MPEG-Dash and the other ingest mechanisms are like massively degraded by the fact that you're going to layer it over TCP and TLS. And so I'm kind of the view that anyone who's doing this over turn TLS has already lost. Now, I've got no implementation experience of that, so I can't tell if that's true, but that's my instinct. So that and I think the other aspect is I think Cullen is largely right with this, that Ice Lite will do everything we want and it will make the thing quicker. And I see no need for trickle. I can't see a use case where trickle is useful. I may be wrong, but I can't think of one.
Okay, that's fair. And just to respond to the question that Colin asked during his comments, I'm gonna have to think about it a little bit more, but the description sounds pretty persuasive that trickle ice may be something we don't need in the grand scheme of things.
Okay, we have a very big queue. Jonathan?
Yeah, so just actually going even a little bit beyond Colin, if you can assume that the server is UDP reachable, you don't actually even need the prospective address. You can just put, your host address or a dummy address. The server gets the client's address as pure reflexive. You don't need any stun or turn servers at all. The only case is, the previous discussion, if you do need to worry about cases where UDP is blocked entirely, then yes, you do need to worry about getting some TCP-based, probably turn server or candidate, which adds complexity, which is annoying. But if we want to say, no, we assume UDP is reachable for this to work, then you can just, I simplifies it a lot. Basically, the client, particularly the client logic simplifies a lot. It doesn't really need to do much at all.
Thank you. Luke?
Oh, hi, Luke from Twitch. Just wanted to say that I agree. Yeah, you don't need ice trickle. The idea here is that the server has a NAT, as the slide points out, but it's really a load balancer that a port forwarded. So long as it has a public IP address and port, it discovers the peer's address via the IP source, source port and IP address. So yeah, it's something that we've been struggling with too. Is just like how do you want a long-lived connection or not? Do you need it? But in the case of ice trickle, if you just have a public IP address and port, you really don't need this. It'd be nice if you could try to combine turn with your existing TCP connection you just made to initiate the connection, but I don't have any ideas there.
Jonathan, you're still in the list, but I'm going to remove you. You can add you on the back if you need. Colin, you next.
So I wanted to talk about restart or whatever. I mean, we had the use case Adam, illustrated just a few minutes ago where something went wrong and he had to rejoin his media. I think we have lots of cases where clients need to redo media. Sometimes it's somebody just switched Wi-Fi networks, or they went from cellular to Wi-Fi or something. And I know that that's going to have a hit on the environment, but if we could have pretty rapid recovery, like less than 2 seconds of the media when the client's IP address possibly changed or redid something, I was going to argue that that would be a good thing. However, I think Jonathan Linnet's comment from a second ago sort of highlights that, like, we're going to get that for free. It's no big deal. Actually, the client will just reconnect to the same address because the public IP and port of the server won't have changed. But where it's coming from the client might change. Anyway, I think we should talk a little bit about that, of like how we can have rapid reconnect of media type thing would be a good thing. And I sort of assumed that ICE restart would be sort of part of that, but maybe it's not.
So guys, I'm just going to interject here for 1 minute. We have 30 minutes left. I understand, Adam, you still want to speak about media type, and then after we have 5 minutes for Lorenzo, and we have 2 extra points, authentication and ICE. ICE we're speaking right now, so we okay, but we have 20 minutes of discussion left. So
right. I don't expect the media type conversation is going to take very long. It was more a matter of flagging it for people's attention. I could be wrong, but I think this is probably something that's really important to nail down. Because whether we need to do ICE talk, and this speaks a lot to whether we need some sort of session construct, right?
Yep, go ahead. So you wanted to speak about ICE restart in response to Callan, or did
Are you talking about Lorenzo?
Lorenzo is in the queue, yes.
Oh yeah, sorry, I didn't know you were talking to me. Sorry about that. Yeah, so first of all, so don't worry about my 5 minutes because they're probably going to be 15 or 30 seconds. It was just some comments on Adam's presentation, so it's not really going to take that long. But I just wanted to add some notes about the trickle itself, which I agree is not really needed because, as we've seen also in the early prototypes, P-Reflexive can do the job as long as you have a publicly reachable address for the server, so there's no problem there. I still think it's a nice feature to have, especially if it's, let's say, optional, and if you actually really want to convey this information, you can somehow. And mostly for reasons that I would say are, let's say, figuring out some ambiguities from a service side of things. Because if all you see are P-Reflexive addresses, you lose the view or the perspective of where that P-Reflexive address is actually coming from. Because, for instance, your client may actually be making use of a return server, even if it's not advertising the candidate via trickle, but it may still be reaching your service via P-Reflexive that way, so, for instance. So even though there are, let's say, some hacky ways to figure out where the candidate came from a service perspective, you may still be interested in some, let's say, statistics in how your users are connecting to the service. So how many ended up using turn for one reason or another, how many are using server reflexive, how many hosts, or this kind of things. So not something that I personally need, but something that some services may actually have some benefit from. So this is something that I do believe is something that trickle may convey one way or the other.
Okay, Jonathan?
Yeah, so I think we, on the sort of general ICE, the ICE restart question, I think we need some story and good answer for the various high availability cases, both client failover and a server failover. ICE restart might be part of that, or we might discover that the mechanism we need for that, for reestablishing whatever the signaling or a session or whatever, is sufficient to just do failover there. And I think we should sort of understand the whole story there before we decide that ICE restart is necessarily the solution to this general restart problem.
So are you envisioning that we might just like restart the entire session instead? I didn't quite follow that.
Sorry, I was unmuting myself, which lovely, unfortunately, but immediately cuts off your audio. So say that again.
Oh, sorry. No, I was trying to figure out when you're talking about the potentially not needing ICE restarts to handle failure cases, what alternatives did you have in mind?
Yeah, just basically redoing the, if the signaling setup is fast enough, yes, just doing the whole process again from start with some, additional signaling saying, yeah, this is a continuation of this previous thing we were doing.
Okay, so that would necessitate the ability to point to like a previous instance, right? Because we're going to an endpoint and creating a session of sorts, we're creating a thing, right? We're creating a broadcast is probably the way to think about it. And so we'd have to say, this thing that I'm setting up is that broadcast, not a new broadcast.
Yeah.
Okay.
Tim?
So that speaks to doing the 201, because what you get back from the 201 is a resource which you could then talk to again. So you've got a reconnection point, so you don't have to go necessarily through the whole process. You maybe don't need to reallocate some resources on the server side, because you're going back to a resource that you haven't yet deleted.
Right, or it could be any other resource that you communicated during that initial contact, right? I mean, what you've described is compatible with, I think, everything we've discussed so far.
Right.
Okay. The queue is now empty.
Okay, so I assume we'll circle back to this at the end if there's more conversation to be had, but I guess for now, go on to the next slide.
Wait. So Julius, you were the other one stressing the need for ICE restart. Do you want to state your use case again? As Jonathan was asking for the story and the use case.
Okay, so the use case I'm speaking about is you're giving a lecture to 100 students. And you wouldn't imagine how bad the networks are. If you have 100 students, you can afford 3 or 4 people not being able to follow your lecture. If 20 people don't follow your lecture, you have a problem. And now most of the students some students are on, ordinary home networks, but a lot are connected over 4G. And you guys all know what the 4G operators do. Some are on university networks, and you people don't know what the university system administrators do, but everything is firewalled, and everything is extremely unstable. I've seen sessions going over 5 IP addresses where the WebSocket was staying connected. So the NAT implementations are absolutely frightening. And in this situation, you want to have a robust enough session that your lecture doesn't get interrupted. In practice, we have found that 2 things are essential. It's falling back to TCP, okay, and you need to very carefully choose your server-side TCP port. So in practice, we have found that what works well is using the OpenVPN port or the Cisco VPN ports. And the other thing that is essential is that when a NAT has a hiccup, you need to restart ICE. So restarting the whole session, if it takes 2 seconds, is okay. If it takes 20 seconds, is not okay. Okay, ICE restarts work beautifully when the NAT has a hiccup. Does that make sense?
Right. So if I understand, you don't really care if it's ICE restart as long as there is almost continuity in the flow. So if
Absolutely.
The mechanism,
the actual mechanism is irrelevant.
Right. Okay. That's an important point, I think, moving forward when we have benchmark of implementation.
Right. So for the notes, I want to flag that as another requirement that we're going to want to document as part of our solution.
Yeah, that makes sense. Thank you, Julius. And by the way, the bad university network you speak about, it's the French university network, right?
I suspect it's probably.
You are trying to get me into trouble here.
I'm just making sure which IT guy I need to go to.
So, okay, I'll just say a few words. Most of the university networks were set up in the 1990s by people who had to deal with Windows 95. And it's always easy to firewall a network, but then the political issues with getting it unfirewalled 25 years later are next to impossible. Okay, so the networks, the student networks, the undergraduate networks, tend to be badly firewalled, and you need to very carefully find what are the ways to actually get traffic into the internet from them. Okay, and I'm not going to give you any names. I'm sorry.
No names. All right. What happens at the IETF stays at the IETF. Fair.
Thank
Adam,
you.
Last slide.
All right. Yep. I was gonna say the last thing that I wanted to hit on, because it wasn't really touched on at all in the initial proposal, was we want to have some agreement on what stream ordinality to expect. So I think there was kind of an assumption that any session that we set up is going to have 0 or 1 video streams, 0 or 1 audio streams, and then no application streams unless we have some additional like extensions that we use to negotiate those in the future. Like I said, it's a matter of we want to document this, but before we write something down, I want to make certain that there are not objections to the prospect that any given session is going to have, like I said, 0 or 1 video, 0 or 1 audio. I see Sergio in the queue.
Yeah, if you're done, Adam, I'm going to let Sergio take the mic. You good?
Yep.
Okay, Sergio.
I was not expected to be so quick, but yeah, you can finish. Yeah.
Well, I mean, I wanted to see if there was discussion around this specific point before we moved on to the next.
I think that there is a use case that we have found is, for example, having multiple audio tracks for different languages. So this is a use case that we may need to support. It's like at the end, it will be only one track that will be the one that will be selected, but having different options for having an input. I mean, I don't know exactly how this could be supported. I think that maybe SDP has a language option or something like that, but maybe it's a use case that we may consider.
Yeah, there are definitely language tags for that kind of thing, and if that's a requirement, we can work it out. But what I heard at the end there was that after the negotiation completed, there would still be only 1 audio stream. You're just performing some sort of negotiation in the middle to determine which audio stream the client elects to send. Is that accurate?
Well, in my use case will be that the encoder will not renegotiate and will send all the languages at the beginning. So the server will allow the clients to choose which one, but it is not. It's not something that it is dynamic. It will, for example, it will send one film in Spanish and English and whatever, and then the client can choose which is the language that he wants to view the film or the stream or whatever. But it is not.
I'm sorry, when you say client, you're talking about the watching client, not the broadcasting client. Is that right?
The watching
Okay,
client. Yeah,
that's why I got lost. Okay. So you would still have the broadcasting client would have multiple audio tracks that it's inputting into the network.
Yep.
Okay.
But it will not be negotiated, or it will just send everything, and then the client will choose, the watching client will choose which language he wants to listen to.
And is this something do you expect to have negotiated between the client? Like, how would the client know that the network is prepared to receive this kind of input?
That's I would say that it will send it in the offer, and the server will, if it accepts it, it will just accept all the tracks, and if not, it will just choose one.
Okay, all right. So we probably want to work through what the scenarios are here. It seems like an eminently reasonable requirement. It's, again, for the notes, let's go ahead and collect that as a potential requirement on the solution, so we can make certain.
Adam, now 3 other people in the queue, but in the context of my understanding, is there any reason why you would divert from 8860, the multiple media type per station, or the latest RFC that touch on the subject? Any reason you would like to do something different than WebRTC is doing?
Oh no, the question of like what to put in the SDP if we want to do this sort of thing is pretty straightforward. But like if you look at what the whole, like what base WebRTC says, I could send 12 audio streams and 24 video streams, and that would be well within spec. But it's probably not something we want to engineer just a typical broadcast ingest protocol to support, right? There's some sort of application agreement of what you want to do. And that's what I'm hoping we can go ahead and put some constraints on here.
Okay, Tim, thank you.
Yeah, so I think the constraints on this and the rules here should be external to WISH. Like if your media encoder wants to send like 3D video and multiphonic stereo and is using 7 WebRTC tracks to do that, that's fine. It's not WISH's problem to understand that. It's a private, not private, but that's a statement between the ingest engine and the encoder that's generating this traffic, and Wish doesn't have anything to do with it. That's not Wish's problem. So we shouldn't need to know, in my view.
Thank you. Harold?
And the easy example is talking head plus slides. Agree completely with Tim. The client should ask for what he wants. The server should just reject the media sections it doesn't support. None of Wish's business.
Okay. Mike?
Yeah, I was just going to relay a comment from Julius, and I missed exactly what he was responding to, but the comment was, you stream video plus audio plus slides plus virtual Blackboard.
That's a good statement. Is there a question to go with it?
Okay, if I may. So you were making the point that there is just one video plus audio session being streamed. I think that the requirement of streaming your face plus slides plus a virtual Blackboard is fairly common.
I understand. The consensus in WebRTC so far was that as far as WebRTC is concerned, I know three things. I know video, audio, and data, right? Whether your video is your webcam or another source or a slide or 360, it's at the application level. So I'm going to let you put a label here so you can recognize which one is which. But as far as WebRTC, SDP Referencer, and GCEP is concerned, I don't want to know that difference.
Okay, so there was a misunderstanding. What I was worried about was limiting to just one video, which would force you to remix video at the server.
No, as Adam said,
okay,
there is no...
Then I didn't understand the point of that. Sorry.
So since 8108, since now we have new RFC number, I'm trying to get to remember them. 8108 is multiple RTP stream per session. You can have as many video, as many audio, as many data, but you're limited to do 3 times.
Okay, but Julius raises a really good point here, which is, for example, if we're bringing in multiple video streams, then if we have any hope of basic interoperability, we need to have some means of the ingest network knowing which one is which, right? So if I create a broadcast client that is doing, here's my headshot, here's my whiteboard, or here's my video game, or whatever it is that you're choosing to put as your second stream, then the ingest network has to know which is which. And that's fundamental interoperability. That's not something we can just say, it's up to the two of them, because then it's like you're back to having bespoke clients for every network so that you can signal which stream means what. And that's kind of why I put this here. If we want to have that ability, then we're going to have to specify it, leave it for an extension, or miss out on a huge chunk of interoperability.
Or decide, like RTMP, to have one WISH signaling channel per session and leave it to the application and the infrastructure to decide which is which.
Well, so you've reduced it to a previously unsolved problem there, right? We still need some way for the tools and the networks to understand what each stream is under those circumstances. Right. And I'm okay tackling that if we think that's a requirement. Alternately, if we have a sufficiently extensible, session-based setup here, we can add this as a future extension. And I think that's probably a reasonable approach as well.
In the spirit of time, I will go through the queue. So I have Luke, Sergio, and Callan. And since we have only 10 minutes left, I'm going to cut the queue there. And we're going to do a small wrap-up. So Luke.
Hi, just wanted to pitch as well a possible another stream. A timed metadata, the idea is that you can send data that relates to the stream, but is not necessarily audio or video. In the RTMP world today, we do it with ID3 tags and whatnot. but it may also be a case to just have this dedicated like data channel stream or something to say this is data that persists to these timestamps, and that would be something that would be, yeah, you'd want it to be customizable based on yeah.
Okay, Sergio.
Yep, just regarding the stream ordinality, I think that the both cases that have been presented so far, that it is the multi-language and the different slides and things like that, can be implemented with some SDP attribute that already exist. So we consider that we want to support it, we may be able to do that with the existing FCCs and not have to implement anything new.
So I just think that we need to make this let's just say we added some tags to the SDP that allowed you to tag an audio stream with a language, or maybe it's already there, or a video stream or an audio stream with this is like a couple common well-known tags like slides, whiteboards, presenter, perhaps a few others. I mean, I think that's absolutely mandatory for interoperability, particularly with non-web clients. I think it's one of the things we've had huge mistakes before. Like, there's there's been whole working groups that were trying to figure out which video stream was the right and which one was the left. And just saying this is up to the application doesn't make any sense, because you want to stream stuff up from a client that wasn't necessarily made by the same person as the media servers. That's the whole point of why RTMP is successful. I think that we really need to take this on as a requirement, as a way to be able to map video streams to semantic slots in some cases. That's just my 2 cents on it.
I do think we need to address the question of, are we making a service or are we making a component? If we're making a component, this is strictly out of scope. If we're making a service, this is strictly in scope. Which are we?
Good question. Adam?
World's characterization there, I think we are making a service, right? The fact that we've constrained this to be a broadcast network ingest really points to it being a service definition. So I think that we need to nail it down. I mostly got in the queue to basically say that Cullen did a very good job of explaining my concerns in a way that I apparently wasn't as good at. So just a huge +1 to what he said.
All right. We have a few minutes left. We didn't speak about authentication at all. This is a matter I will put back on the list for discussion, if there are people that want to discuss it on the list. If there is any people new to IETF, most of the final decisions are taken on the list, even if we make any vote or anything during the meeting. So please join the list and participate into the discussion moving forward. This is just the beginning. I can see there is a lot of points, maybe half of the point we discussed today that require clarification. I believe the documents are going to be greatly enhanced between now and the next meeting in San Francisco, or virtual from supposedly San Francisco. And I will try to send you the notes and the different points with Sean in the week to come. So unless there is any big item that people would like to speak about now, I will give you back 5 minutes to have an extra 5 minutes on the break.
So I have a question, which is, how do I save these notes? Where do I save them to?
Sean, do you know the answer to that?
Yeah, if you did it in CodeEMD, they should just stay there.
Okay, so if I just close this window, they won't just vanish forever.
No,
wait. Lorenzo, can you validate the?
Yeah, well, CodeEMD is not very bad. But yeah, I'm opening the CodeMD tool right now, and I do see team notes, so no worry there.
Yep.
So
as long as you
that's
don't delete
persisted
them-
somewhere interesting.
Yes.
Okay, cool. I'm off the hook then.
Yeah, it's awesome, actually. Thanks. And other people can review them to see if they were mischaracterized or fill in their names or whatever that Tim missed. And thank you very much. And also thanks.
Feel free to correct all the spelling errors which are littered through there.
Yeah, the important part is that we got any decisions that got made. And again, I think thanks to Mike who did the JabberScribe. Somebody did the JabberScribe. I appreciate that. And we'll see you all on the list.